Okay, we shall complete the summary, and I shall give you some more useful information that can be used, and you can refer to the original source of references which I was mentioning from time to time. And I strongly also suggest you may go through a companion textbook or a companion web course or to have more details. And we were lastly dealing with the overhangs and wing walls, and introduced the concept of the shading plane, which joins the edge of the overhang to the base of the window of area A, SHP, AW is the window area, P is the projection, the sun's ray will make Y. These relations have been given, and incidentally a wing wall is something like this, which we have of course dealt in detail in the lectures. I will show only one. If you see some of the buildings, there will be a vertical, or it looks like it is. This is the wing wall, and depending upon if the sun is on this side, like if this is south, this may be west, this will cast a shadow here. So, if you have a overhang and two wing walls, and bottom is not necessary, but usually that makes it a box type window, there will be pretty good coverage. And if I have not yet exactly made the calculations, but I suspect that if you have got wing walls associated with the overhang, you may treat the overhang as if it is infinitely long, because it is either shaded by this or this. So, that is a different issue. And now similar concept can be extended. You join one edge of the wing wall to the base of the window on the other side, and that let me show only one of them, so that it will be clear. So, this is your window, and this is your wing wall. So, from here so this will be your shading plane, okay, the one that joins the edge of the wing wall to the base on the other side of the wall. So, this is the shading plane for the wing wall. Now, you do exactly the same way we have done and calculate the solar radiation falling on the shading plane as formed the way I have described. You will get the radiation received by the window per unit area of the window, introducing Fi for the shading plane. Now, of course, this also has got limitations in the sense this is pretty long, so that the shape of this is always a rectangle. Okay. So, that formally finishes the topics that we covered, but you may be a little curious for certain additional things like solar furnaces and of course, central tower power generating systems. And air conditioning and refrigeration. Cold storages. So, these I have not included because each design is specific and depending upon the location and application, and it is difficult to put it in the form of say QU is equal to ACF or tau alpha type of formula. And if you have got solar furnaces, It is essentially a typically a pyramidal dish, high concentration ratio, and is useful for metallurgical research, because there will be no contamination, and also since they are small quantities, you can afford to have a furnace. Central tower power generating systems are on demonstration and have been successfully integrated with the grid, and air conditioning and refrigeration has not met so far perhaps that much success. One is, if you go through the absorption route, the equipment is bulky. Essentially, I mean low temperature. So, something like maybe a flat plate collector at 90 degrees C supplies energy at about 90 degrees C. So, consequently, your COP will be pretty poor. And if you go for compression system, essentially it is a power, electrical or mechanical generating system. So, if you have electrical power, you can combine with any compression system, refrigerator and operate it. Power generating system. Okay. However, there are n number of I don't know, I am not an expert, metal hydrides, hydrogen halides, etc. being used, and with the absorption principle, and they may meet with some success, but essentially this cold storage also and small scale refrigerators are useful for remote villages, particularly for medicine storage, etc. So, this is in vogue. So, these are some of the things which you may find from time to time. The best thing is to go through journals or even the web, which have many pictures. And the other thing I mentioned was cold storage. Now, one of the things that people will ask regarding solar energy technology, apart from the lot of progress that has been made and the demonstration as well as commercial systems that are installed, our understanding has improved, and many rules of thumb can be avoided now, can be calculated with reasonable, accurate formulae. This is particularly evident in the architecture the sun path diagrams of the sun's position, shadow length, everything can be estimated now. Similarly, even if you consider a cold storage, you can choose a good orientation and A by B by C or land area by the height ratio of a cold storage such that it receives the minimum solar radiation, because subject to certain constraints like a certain height, and you can choose play with A, B and what direction it shows, it sees, rather facing south, north, east or something else, and this may help in reducing the heat load on the structure, similarly on any other building. So, if you want any clarification, sometimes because these are all handwritten and of course, every frame will be there in your video, you can go back and see, but still nobody can guarantee that it is completely error free. There may be some mistakes, plus, minus, etc., and one star may be missing, one star may be extra. But if you want any clarifications, you can contact me at vvsmurthy@mac.iitkgp.net.in. And the other thing is number of problems we have solved, which I will show here, so that they are all at one place, but the solutions you have to pick up from the corresponding lecture, and the number of the lecture also I have indicated along with the problem, so that it will be convenient for you to go back to that chapter or lecture number and see the steps. And there are additional problems also I have given, and these are deliberately given, and rather I did not give the solutions to this, and if anybody is interested in the correctness, he should do a little bit of exercise, do homework, send me to the email your answer or the solution or both, then I can help you solve it, and you put in your effort and I shall give you the correct answer if I am that is it. So, first from the diameter of the effective sun, etc., we have made calculation, different angles of incidence, these are all under exercise 1. Then direct radiation, sunset hour angles shows essentially the difference between the days and how latitude affects these things, and similarly the day lengths are calculated here. So, there are up to 1.12 I think I have solved, and 1.13 to 1.17, 18, 19, these are the additional problems, you can solve it, and but then let me also tell you the methods to solve these problems are available when we solved F chart and phi bar F chart problems. So, exercise 2 I just put it in the form of exercise 2 only, because in this form of delivery exactly you have to match the time, sometimes it may be little less, sometimes it will be little more. So, they were all called exercise only, and this is the phi bar F chart method and then number of extensions to the same problem, and I have given you the India environmental portal where you can get data. In fact, that is true for including ambient hour temperature, and another problem with the F chart method, and this is an interesting thing, I did not do it earlier, that if you compare the liquid based system F chart and phi bar F chart method, and they give pretty comparable results. And I have put all the websites I have gone through, which was a revelation here. Those of you who are interested, just click it and see, and then horsepower, maps of India, and this is the deals with the solar pricing. That is where from I have taken the data for economic analysis. And here I have put all the references starting with the classical book by Duffy and Beckman, Solar Engineering of Thermal Processes, and some of the theses that have been submitted to IIT Kharagpur, and key references like Argyll and Holland, Scholar Esperer, Robel, Winston, and which have been Leo and Jordan, which have been referred time and again throughout our lectures. And then these are the later studies done at Energy Lab, IIT Kharagpur, which will throw some light how the classical, for example, utilizability calculation, double sunshine, and solar radiation under terrestrial, extraterrestrial conditions, and some ambient temperature predictions. This is the data book by Mani and Rangarajan, aerological data. Then this you can now I believe it is TMY3. You can have the data downloadable for about 240 US locations of 27 meteorological variables. You can have the data and take comparable latitudes of an Indian location, say for example Mumbai or even Srinagar, Delhi, and that goes as low as I think 25, 24 degrees, even the North American, or even lower. So you have corresponding locations and check how the solar radiation compares in the Indian subcontinent and the US. And this is a book, Loaf, the at this Loaf used to do the solar house 1 and solar house 2 actual system scale experiments. Handbook of Applied Meteorology, you can see Introduction to Climate. This is a general knowledge, generally good knowledge book, and you may see that Kerala, for example, in India, Assam and Rajasthan, how climatically they are different and how they are classified, and according to that you can have an idea of what type of solar radiation one can expect. Again, these are the studies done here, and this is one of the papers where economic viability has been studied along with Professor Beckman, and this is again you will find that Klein, Brandmühl and Beckman, which we have referred number of times, and McAdams is a classical heat transmission book, which you can see number of relations, whether or not we have dealt directly in here or not, you can find them. Particularly it will be useful for calculating the flat plate collector loss coefficients. So this is a just Blasius equation that gives you the frictional pressure drop, and these are all the additional solar collector geometries. Again Raubel, Francis, Soulcast, another simulation program, a computer in the design of solar energy systems by Klein, Mitchell, Duffy and Beckman, and sets of data how to reduce and use a simpler data set rather than a voluminous data. Those advantages also have been found out, or how you can do that. So this is the typical list which I have used. They might not have been exactly numbered in the lectures or in my handwriting. Some of them I might have orally told, but nevertheless you can just go through these things in the appropriate, from the title you can find out where they do become relevant for the topics that we have covered. So that's it. I enjoyed giving you these lectures, and I shall look forward to your queries, and I shall answer through email, and consequently don't hesitate. I shall not do your homework or the assignments, but related to the subject you can send a problem, and I don't promise you will have the answer in 24 hours, but you may have the answer within a week. Thank you very much.